In this video, we are going to see about constraint satisfaction problems in AI. What is CSV? Here, the states are defined by variables like x1, x2, x3 and its own values from the domain D. Here, whether we reach the solution or not, that will be done by the goal test with set of constraints. For example, we can go for coloring the room or map using this constraint satisfaction problem. For example, consider this graph. In this graph, we have states like Western Australia, Northern Territory, South Asia, Queensland, like that. These are all represented using these variables. And here we can pick the value for the variables from the domain D. Here it's a coloring problem, so here we can go for using red, green, blue. Okay, here the constraint is adjacent region should not have the same colors. That means if we are going to color for red here, then this should not be red color, this should not be the red color. If it's a red, then NT may be the green or blue. Here this may be that. If it's green, that should be the blue. Like that we are going to color. For example, here we can go for involving two variables here. This can be converted into that constraint graph. Here this WA, NT and SA. This constraint graph, for example, we are going to color with red color. Then this should be with the green or blue. Again it's red and green. This should be the blue color. Keep on moving like this. Every time we are going to check whether this is satisfying the constraint or not to reach the goal. Finally we'll get the solution like this is a red color, then it's a green, blue, red. So here in this all adjacent states are having the same color. This way we are checking this goal test for checking constraints. Here the constraint may be unary, binary or higher order. The unary constraint may be a single variable. It's going to be compared with that value, not the variable. You have only one variable like states. But binary we are going to have two variables. Here we have two different states. Then more than two variables, it's called higher order constraints. The next one is about crypto-arithmetic puzzles. Then crypto-arithmetic puzzles, it's for solving mathematical exercises where the digits of some numbers are represented by letters or symbols. Then each letter represents a unique digit. The goal is to find the digit such that the given mathematical equation is verified. This purpose we are going to for this arithmetic puzzles. For example, here we have a send plus more is equal to money. Initially no values are assigned to this variable like A, C, N, D, M, O, R, E. Then you can have some values, digits like 0 to 9. Then the goal. We have to assign one value to this, unique value to this each variable. For example, here you can go for this ACND and with MORE, then you have to get money. So if you are assigning a number to this S and M, if you add, you'll get the result like MO. Then E and O, that should be N. N and R, E. Then E, Y. This E and E should have the same value. The letter should have the same value wherever it is. So first take this S plus M, that should result in 2 digits. Adding two numbers should result 2 digits. Then take some minimum values like 1 plus 9, that results 10. So you can get this M is 1 and O is 0. Again take this E and O, that should result in. If you add this number, any number with that 0, because O we got 0 here, n number plus 0, that should result 0 no, it is not possible. We cannot assign same number for two different letters. So what we can do is we can get some carry from the next digit like n plus r. So timing we'll go to the next one, n plus r. N plus r, take some number, add, we'll get 1 plus 5. This 1 will be given to this E plus O. So 1 plus 5 plus 0 we may get some value 6 here. So that n6 here also, this n is also assigned with 6. Both values are same. Okay, proceed. Then D plus E, take some numbers, you have to give the carry to your next number. Finally, if you add this SEND you'll get this MONE. These are the numbers we are getting from this calculations. This way you can go for the script arithmetic problems. In real world, this may be useful for solving assignment problems, timetable, and transportation scheduling problems and factory scheduling problems.